All right, so let's talk about carbon dioxide being added to water. Your first intuition here might be to call this a double replacement reaction or an acid-base it is an acid-base reaction, but to call it a double replacement reaction because I've got two compounds. However, this is one of those exception to the rule problems that everybody loves, and this is actually an addition or a synthesis reaction. So what I can identify here is I can identify that water is going to be my acid, and water will be my acid because it contains hydrogen. And so what will happen here is the water will donate its protons to the carbon dioxide. And so you're going to put both hydrogen, or excuse me, water and carbon dioxide together, and you will end up getting what we call hydrogen carbonate, where I've got carbonate here with a -2 charge, hydrogen with a +1 charge. And so this is completely soluble in water. So the equilibrium basically favors both sides, where K is almost going to equal 1. The acid in this case, as previously mentioned, is going to be water. The base in this case is going to be your carbon dioxide. Your conjugate acid is all you really have here, is your hydrogen carbonate. There is no conjugate base in this case because it's a synthesis reaction. So now what you need to recognize here is that since the equilibrium constant is basically 1, all three of these species are going to exist together in almost the same concentrations. So I'd like you to think about that when we're talking about carbon dioxide in our atmosphere reacting to the water that is in our vast oceans, and thinking about that in terms of climate change. I'm going to attach a couple videos on the next slide that are going to talk about ocean acidification. And for those of you who are interested in pursuing your IA, something with an environmental theme to it, this is a really good opportunity to maybe kind of flesh out what your IA question might look like.